Bismillahirrahmanirrahim. Rabbi shrah li sadri wa yassir li amri wahlul 'uqdatam min lisani yafqahu qawli. Assalamu alaikum students. This is Hamza Noor. Today we have some questions from ASP1 circular major topic past paper handout. First of all, we have question number 20. So the question is saying that in the diagram AB is equals to AC, which is equals to 8 centimeter, and angle CAB is equals to 2 pi over 7 radians. The circular arc BC has center A. The circular arc BC has center A. The circular arc CD has center B. The circular arc CD is having the center B, and ABD is a straight line. Show that angle CBD is equals to 9 pi over 14 radians. Angle CBD. All right. So first of all, what we can do over here is find this angle. Since you know the fact that this side is equal to this side, so the angles which are opposite to these sides are also supposed to be equal. So this means that this unknown angle CBA and this unknown angle BCA are supposed to be equal. So since sum of all angles is equals to 180 degrees, but we are talking about the radian mode, so sum of all the angles is supposed to be equals to pi. So we can say that 2 pi over 7 plus angle CBA plus angle BCA is equals to pi. So therefore, I mean, these two angles are supposed to be equal. So let's take them x, take this angle x. So 2 pi over 7 plus x, meaning 2x is equals to pi. Therefore, 2x is equals to pi minus 2 pi over 7. This is supposed to be 5 pi over 7. So x is equals to 5 pi over 14. We have made x a subject. So x is equals to 5 pi over 14. And sum of all angles on a straight line, the supplementary angles, the sum is equals to pi, which is 180 degrees. So therefore, we can say that angle CBA plus this angle CBD is equals to pi. Therefore, 5 pi over 14 plus angle CBD is equals to pi. Therefore, CBD is equals to pi minus 5 pi over 14. So this is supposed to be 9 pi over 14. This working was just for 1 mark. Now part 2 is asking find the perimeter of the shaded region. I'm erasing this working completely. You need to find the perimeter of the shaded region, which means that you need this side, you need this arc length, and you need this arc length as well. Now, in order to find the arc length CB, what you can do, S is equals to R theta, where theta is in radians. So arc length CB basically is equals to radius of 8 centimeter, 8 multiplied by 2 pi over 7. So this is basically 16 pi over 7 centimeter. This is arc length CB. Now, talking about this arc length CD, this arc length CD is having a center of point B. So this angle we have already found, 9 pi over 14. But right now we don't know this side. We can actually find out this side by using the cosine rule formula. So we can use the cosine rule formula like this. CB square, let me just erase these things. CB square is equals to AC square plus AB square minus 2 times AC times AB and then multiplied by cos CAB. Okay, So CB square is equals to 8 square plus 8 square minus 2 times 8 times 8, and then multiplied by cos 2 pi over 7. So you can find out the value of CB. So 8 square plus 8 square minus 2 times 8 multiplied by cos 2 pi over 7. The value of CB square is 48.193, and under root of this answer, CB is supposed to be 6.942 centimeter. CB is 6.942 centimeter. All right. So this CB is actually equals to BD. So this length BD is the, the radius of the circle. Okay. This is 6.942 centimeter. So in order to find the perimeter of the shaded region, what we actually know right now, that this arc length CB, this length BD, now we need this arc length CD. Now in order to find the arc length CD, we'll apply the arc length formula again, r multiplied by theta, where theta is in radians, and this angle is basically equals to 9 pi over 14. So 6.942 multiplied by 9 pi over 14. 6.942 multiplied by 9 pi over 14. This is 14.020 centimeter. So in order to find the perimeter of the shaded region, we need 14.020 centimeter, 16 pi over 7 centimeter, and this arc length basically, which is CB and which is equals to BD, 6.942. So you add all these three values, 6.942 plus 14.020 plus 16 pi over 7, and the final answer is supposed to be 28.143. So correct to three significant figures, your answer is 28.1 centimeter. Let's move on to the next question. All right, so here we have question number 22. The question is saying that the diagram shows a circle with radius r centimeter and center O. Points A and B lie on the circle. Points A and B lie on the circle, and ABCD is a rectangle. ABCD is a rectangle. Angle AOB is equals to 2 theta radians and AD is equals to r centimeter. All right. Express the perimeter of the shaded region in terms of r and theta. Now, in order to find the perimeter of the shaded region, what you know is that this AD length is r centimeter, so definitely this BC length is also r centimeter. We don't know this CD yet, and we don't know this AB yet, but we can actually find out the length of this chord AB, which will be exactly equal to the length of CD. All right. So what we know, the fact is that we can actually find out AB in terms of R. Okay. So here we have the symmetrical property of circle, which we have studied in O level and IGCSE mathematics. All right. So if this point is X, this is basically the midpoint of AB. All right. And this AX will be equals to XB line. So here we actually have a right angle triangle. We can say OXB, and this OB is the hypotenuse, r centimeter, and this theta will, this whole angle 2 theta will be divided into equal parts. So this angle is supposed to be theta. We can actually find out XB in terms of r and theta. So opposite over hypotenuse, sine theta is equals to opposite, which is XB, divided by hypotenuse, which is OB. So sine theta is equals to XB divided by R. So we can say that XB is equals to R multiplied by sine theta. Now this is basically XB length. When XB length is multiplied by 2, this will give you actually the length of AB. So AB length is supposed to be, AB is equals to 2 multiplied by R sine theta. and this AB will be definitely equals to CD. So hence we have found CD 2R sine theta. We need what we know right now. What we know right now so far, that this CD length is 2R sine theta, this AD is R centimeter, this BC is also R centimeter. Now we are actually interested in finding this arc length AB. And the formula for the arc length is S is equals to R theta, where theta is in radians. So this theta, this angle is completely 2 theta, and the arc length AB is supposed to be, I can actually write AB right now, AB over here. So R multiplied by 2 theta. Okay, so this is 2R theta. This is the length, arc length AB. Now, in order to find the perimeter of the shaded region, what we want, the arc length AB. Okay. Arc length AB plus AD length, plus this CD length, and plus this BC length. So arc length AB is 2R theta, AD is R centimeter, CD length is 2R sine theta, and this BC length is also R centimeter. Okay, so 2R theta plus 2R plus 2R sine theta. Okay, so I mean, you can leave your answer in this form. It's completely fine. 2R theta plus 2R plus 2R sine theta, or what you can do is take 2R common, so multiplied by theta plus 1 plus sine theta. This can be, I mean, this can be left as your final answer as well. All right. Let's move on to the next part. The next part is saying that in the case where R is equals to 5 and theta is equals to pi over 6, find the area of the shaded region. Now, in order to find the area of the shaded region, what you want is first the area of this rectangle ABCD. All right. And from that rectangle, you will actually subtract the area of this segment, which I have just shaded. Okay. So in order to find the area of rectangle, this is so simple. We don't actually need this working now in the further calculation, because this is related to the parameter, but still I'm, pasting it at the top. Now we are solving part 2. So first of all, we have the area of triangle ABCD. So length into breadth. So area, sorry, rectangle, not triangle. Sorry for saying triangle if I said that. Area of rectangle ABCD is basically 2R sine theta multiplied by R. 2R sine theta multiplied by R. Now we are dealing with the case where R is equals to 5 and theta is equals to pi over 6. So area of the rectangle is actually 2 multiplied by 5 multiplied by sine theta. So theta is supposed to be pi over 6. And then again multiplied by 5. So this is 2 times 5 times 5. This is 50 multiplied by sine pi over 6. So the area of the rectangle is supposed to be 25 centimeter square. 25 centimeter square. Now we will actually find the area of this segment, which I shaded earlier. Now, in order to find the area of the segment, what we can do over here is first find out the area of this sector AOB, and then subtract the area of this triangle AOB, so that you will get the area of the segment. Okay. So for this purpose, let's first find out the area of the sector. So area of sector, the formula is half R square theta. We are finding area of sector AOB. So 1 upon 2 multiplied by r square, but theta is basically 2 times theta. So in place of theta, you will write 2 theta. So this 2 and this 2 will cancel out. Therefore, r square theta is basically the area of sector. Now we are dealing with the case where r is equals to 5 and theta is equals to pi over 6. So 25 pi over 6 is basically the area of the sector. Okay. Now we are interested in finding this area of triangle AOB. And for that purpose, we have the base AB and we can find out the height now. Or what you can do, you can just simply apply the sine rule formula, half r square into sine 2 theta. The sine rule, which you have studied in O-level math and IGCSE maths, half times AB times sine C. Okay. So, I mean, instead of finding the height first, you can actually directly apply the sine rule over here. So now I'm finding the area of triangle AOB. Area of triangle AOB. Half into AB into sine C, so half into R, meaning half R square, multiplied by sine 2 theta. Sine 2 theta. And we are dealing with the case where R is equals to 5 and theta is equals to pi over 6. So sine 2 pi over 6. So find the value of area of triangle AOB. You can just write that you are finding the area of triangle AOB, not the sector AOB. 1 upon 2 multiplied by 5 square multiplied by sine 2 pi over 6. This is 25 under root 3 over 4 exactly. 25 under root 3 divided by 4 centimeter square. Now, in order to find the area of segment, what we will do, subtract the area of the triangle AOB from the area of the sector AOB. So area of sector AOB minus area of triangle AOB. Okay, so area of sector AOB is how much? That was 25 pi over 6 centimeter square exactly. So 25 pi over 6. Take away the area of triangle AOB, which is 25 under root 3 over 4. Okay, so you will get the area of segment. So 25 pi over 6 minus 25 times under root 3 over 4. This is 2.2647. 2.2647 centimeter square. This is the area of the segment, which I've shaded over here in brown. Now, in order to find the area of the shaded region, we can subtract the area of the segment from the area of this rectangle. So area of the rectangle, which we initially found, was 25 centimeters square. So area of shaded region is equals to area of rectangle minus area of segment. Area of rectangle is 25 centimeters square. So 25 minus the area of segment, which is, we just found out, 2.2647. 2.2647 centimeters square. So your final answer is supposed to be 25 minus 2.2647, and this is 22.7353 centimeters square. So correct to 3 significant figures. Your final answer is supposed to be 22.7 centimeter square. So here we have question number 24 from the handout. The question is saying that the diagram shows an isosceles triangle ABC in which AC is equals to 16 centimeter and AB is equals to BC, which is equals to 10 centimeter. The circular arcs BE and BD, BE and BD have centers at A and C respectively, where D and E lie on AC. ठीक है, हमें भी पता है. Part 1 is saying that show that angle BAC is equals to 0.6435 radians, correct to 4 decimal places, just for 1 mark. So basically what you know is that this is an isosceles triangle ABC. All right. So if I take the height over here, okay, this is a height, and this basically this line will act as a perpendicular bisector of the line AC, of this complete line AC. So since this complete line is AC, which is 16 centimeter, if this point is X, what I can say is that AX is having a length of 8 centimeter, and similarly XC is also having a length of 8 centimeter. Okay, so this AX length is 8 centimeter. So what we can do over here is we need to find this angle BAC. So we don't know the opposite side, but what we know is that the hypotenuse and the adjacent side. So cos theta is equals to adjacent over hypotenuse. Cos BAC is equals to, this adjacent side is basically 8 centimeter and hypotenuse is 10 centimeter. So BAC is therefore cos inverse 8 over 10. Cos inverse 8 over 10 and correct to 4 decimal places, 0.6435 radians. We have the answer. This working was for 1 mark. Coming on to the next part, we need to find the area of the shaded region. All right. Now, in order to deal with this scenario, first of all, let's consider this whole complete sector BAE. Okay, let's first find out the area of this complete sector BAE. So for that purpose, what I know that the area of sector formula is half r square theta. I'm finding area of sector BAE. Okay, BAE. So what we know is that the radius over here is okay. The radius is actually 10 centimeter because this AB length is 10 centimeter. Since this AB length is 10 centimeter, this AE length is also 10 centimeter. So the radius is 10. Half into 10 square multiplied by theta. This angle we already proved, 0.6435 radians. So half into 10 square multiplied by 0.6435. 1 upon 2 multiplied by 10 square multiplied by 0.6435. This is actually 32.175 centimeter square. This is the area of the sector BAE. Okay. Working को या टॉप पे चिपका देते हैं. Then what we can do is we actually just found the area of the sector BAE. Okay, now we can actually find the area of this sector as well. Okay, and since you know that this is an isosceles triangle, this length 10 centimeter, this length is also 10 centimeter. This Sector BDC will also be having the radius of 10 centimeter, and here the angle will be the same. So this area of sector BDC is also equals to the area of sector BAE. Both sectors are having the same area actually. So we can definitely say that area of sector BDC, area of sector BDC is actually equals to the, just ignore this angle. We don't need to mention this. Area of sector BDC is equals to area of sector BAE. All right, so both of them are 32.175 centimeters square. Now the thing is, we can actually find out the area of this triangle. We can actually find out the area of this triangle, which is, let's say this point is X, area of this triangle BXC. All right, and instead of finding out the height, okay, what we can do is apply the sine rule. This angle is also 0.6435. If you just consider this triangle BXC, or you just consider this triangle BXA, it is the same thing. We are interested in finding the area of this right angle triangle. So we will actually apply the formula of sine rule. But the thing is that this side is actually 10 centimeter, but this XC side is 8 centimeter. Okay. So please don't make a mistake over here by just considering this whole length. Obviously, मतलब छोटी सी बात है सर, ऐसे बता रहा हूँ. So area of triangle is supposed to be half into AB into sine C according to the sine rule. Just mention what we are actually finding over here. Area of triangle BXC. Okay, this is half into 10 into 8 multiplied by sine 0.6435. So half into 10 into 8 multiplied by sine 0.6435. This is supposed to be how much? This is 23.99 centimeter square. Just write 23.999 centimeter square. You can also write 24.0 as well. Okay. So basically area of this triangle is equal to the area of this triangle. All right. Now the thing is that we can actually find out the area of this region, which I just shaded in orange. How? If we find out, if we since we have the area of the sector BDC, all right, we have the area of the sector BDC, and from that area we actually subtract the area of this right angle triangle which we just found. So I'll be able to find out the area of this shaded region, which I actually just shaded myself, this orange one. Okay, which I just label it as BDX, which I just label as BDX. So area of BDX would be area of sector, which sector actually? BDC, area of sector BDC, minus the area of triangle BXC, which we just found. Now, since you know the fact that this area of sector BDC is actually equal to the area of the sector BAE, and this was 32.175 centimeters square, and you need to subtract the area of triangle BXC, and which we just found 23.999 centimeters square. So 32.175 minus 23.999. This is supposed to be 8.176 centimeters square. Okay, this is actually the area of this orange region. Okay, this not orange exactly, but light brown, very light brown. Whatever the color is, huh? समझ जाओ बात को. This one is 8.176 centimeters square. So We will, by the same procedure, we will also find this area, but you don't need to actually follow the whole procedure again, since you know that these two regions are exactly identical to each other. So what you do in order to find this, you know, this shaded area which I have just shaded completely right now, you can say that the area of BDE, this area of this region BDE is now basically 8.176 multiplied by 2. You can say that area of region, you can actually identify this as BDE, area of this region BDE is uh, 8.176 multiplied by 2. How much is this? This is 16.352. 16.352 centimeter square, and which is actually our required area. This is our required area, and we just found out. So therefore, your final answer correct to three significant figures is supposed to be 16.4 centimeter square. So this whole working was for 5 marks. This was question number 24, October, November 2017, paper 1-1, question number 5.